equation where everything's a function of x. The argument is a function of x. The exponent is a fractional function of x, and the right-hand side is certainly a function of x. So we're to solve this for x, a real number, and let's get busy. Now, x, a real number. Notice that's the constraint. No complex solutions here. If there are, we're just searching for the real solutions. Now, notice just immediately, since we have the square root on the right-hand side, that we know that the interval, if there are solutions, they will be non-negative. And you guys may have seen this notation, close zero, open infinity, okay? So another way of saying this is just non-negative reals. Non-negative reals, or the interval close, it's okay to have zero, right? Zero is fine in the radical. You just can't have anything less than zero to avoid complex solutions. Now, so it's very convenient here to remember some properties of rational exponents. The big property right here that's quite handy, going from this step to this step, is the result that says if you have some base, some exponential base raised to a power, all right, and then you turn around and raise that to another power, and that's supposed to be b raised to the n power, then you can multiply. Okay, you can multiply the two exponents. And that just follows pretty quickly from the definition of what it means to exponentiate. If you have n copies of m copies, you're going to have m times n copies. So y'all, again, that is supposed to be an m. I think when the Wi-Fi cuts out, this thing kind of slips up a little bit. So that's times, and that's supposed to be an n. So that's b to the m times n. Like that. Okay? And so that's exactly what happened. Our m right here is just x minus 2 over x minus 1, but 2 times that is, you just multiply 2 against the numerator because this is really 2 over 1. So you get that this is equal to x to the 2x minus 4 over x minus 1. So that's an exponent that's a fraction. All right. Now, another result that's quite useful right here is to recall that there's an understood 2 for your index of the radical right here and a 1 for your exponent. And of course, this is x to the first power. You add your exponents in this circumstance. And so what you get is the same base here, x raised to the 3/2, all the way back over here equal to x raised to the 2x minus 4 over x minus 1. Okay, now the exponential function is what you call one-to-one, so you can equate the exponents. Now, just an example of a function that's not one-to-one, just consider x squared. Let's say that you had 16 squared equals to 16 squared. Or let me think of a better example. What if you had a squared equals to b squared? That doesn't necessarily imply that a equals b, because what if it was equal to 16? Well, you could have minus 4 squared, or 4 squared is equal to 16. All right, so it has to be a one-to-one function before you can equate the exponents. So that's what we did right here. We equated this fractional exponent with this exponent right here, okay? Now, at this stage, you might think you can just set the numerators and denominators equal to each other. That doesn't really work all the time because the fraction may or may not be reduced. The best thing to do is just cross multiply. If 2 fractions are equal to each other, you can. It's a certainty that you can cross multiply. All right. So if you cross multiply right here, you get 4x minus 8. 4x minus 8 is equal to 3x minus 3. Okay. Again, y'all, what did I do right here? 2 times 2x minus 4 is 4x minus 8, and 3 times x minus 1 is 3x minus 3. Now, you quickly see if you subtract 3x from both sides and add 8 to both sides, you get x equals to 5. Okay, only solution. All right, now this one isn't too hard to check. So let's take that back to this original right here and actually see what we get. If you put 5 right here, you get 25. You get 25. And again, y'all, that's putting 5 right there, raised to the 3/4. Again, y'all, that's 25 raised to the 3/4. If you put 5 there, 25. You put 5 there, you get 3. If you put 5 right there, you get 4, right? So it's 25 raised to the 3/4 equals to 5 times root 5. Now let's see if that makes any sense, folks. First of all, 20. Y'all. I think I got room right here. 25 to the 3/4 has a meaning, right? It means 25 to the 1/4. Cube. Okay, that is literally the meaning of what it means to raise something to a fractional exponent. Now notice that if you extract the 4th root of 25, you're saying, what do I have to multiply by itself 4 times to get 25? All right, well, that would be root 5. Root 5 times root 5 times root 5 times root 5 is 25, right? Because root 5 times root 5 is just 5. So root 5 times itself 4 times is going to be 25, right? And so this would actually be the same thing as, let me just write it out here. This would be root 5. I'll just put it right here. I always do this to myself, get myself painted into a corner. Root 5 quantity cubed, right? But what is that, folks? That's root 5 times root 5 times root 5. So 2 of the root 5s are going to combine to give you 5. And so that does work out to 5 root 5. Okay. So we did check the answer and it does work out. Okay, folks, so this is the answer to the problem. X equals 5 is certainly the answer. All right, and this is just a check right here, and it checked out. Okay, folks, that is all I have for you tonight. I do hope you enjoyed it. Leave any comments if you have any questions. Thank you.